Thank you for having us here today. This is Xirrus' first time at the Wireless Field Tech Day. We're glad to be here. And we have put together a presentation here for the next couple hours that we'll kind of kick off with providing an overview of the company. We want to kind of set the stage on who Xirrus is. Probably a lot of you are familiar with us, but we want to present an idea of what we do. We do some very unique things on the RF side of the equation. So when we get down further into the architecture, we're going to deep dive into that, show you what we do, what's unique about what we have put together. We also have a customer here that's going to talk to us about his implementations in the real world, some specific examples of what he has done. And then we're going to end up with a real world discussion about high density Wi-Fi. So we're in an age today where there's a proliferation of all types of devices. The capacity and the bandwidth constraints that people are running into from a pure density perspective are very challenging. And we want to talk about how we specifically address those and some best practices for handling those things. So most of you have probably run into poor wireless at hotels or airports or many other places. So I think our message here today is just keep calm, enjoy the wireless experience. Yes, you can get good wireless in a venue with thousands of people. Yes, it is possible. Many of us get frustrated with poor wireless, but it is possible to have a good experience. And that's what we're here to talk about today, is how you can architect a network to do exactly that. All right, so first off, I'm going to introduce to you our founder and executive chairman, Dirk Gates, and he's going to run through an introduction about Xirrus and our solutions. Dirk?
Thank you, Bruce. Good morning, everyone. Glad to be here. Given this is our first time at Wireless Field Tech Day, we figured we'd give a little bit of background on the company. And actually, if you don't mind, I'm going to go into prehistory. If you go all the way back to 1988, I founded a company called Xircom. I'm looking for some of the older guys.
Oh, yeah, right here. Yeah.
I am the founder of Xircom. So we were the first to connect notebooks to networks. Believe it or not, back in those days, that was not standard. So we ultimately became the largest manufacturer of PC card, Ethernet, and modem devices. And if you go back in time, in 1993, we introduced the world's first PC card wireless LAN adapter. Anybody doing the math is figuring out that's 5 years pre-standard. It was a 1 megabit per second frequency hopper. We were able to cram it into a PC card in '93. We also introduced the world's first integrated access point. Prior to that, you'd buy a PC, an Ethernet card, a wireless card, usually an ISA form factor, and put bridging software on it. We had a device that looks pretty much today like what an AP looks like. It was a Spark-based processor, wireless card on the top, Ethernet. So that's where we got started. Flash forward 2001, Xircom's about $500 million a year in revenue and 2,000 employees, and I sold that to Intel and tried to retire. Well, that didn't work too well. A couple of years in, the wife says, okay, you're getting underfoot. You got to go do something else. So that something else turned into Xirrus. And so we were started officially in 2004. And if you look at the problem statement, I'm not going to read the slide to you. I happened to be in 2004, I was sitting on the board of a couple of different startup companies, one of which had Intel as an investor. So I was invited to an Intel Capital conference up in Santa Clara up here. And I sat through an entire afternoon of pitch after pitch after pitch, 3 minutes long, every company that Intel had invested in that had something to do with Wi-Fi, their entire portfolio Wi-Fi related. And I walked away, and this was probably mid-2003, walked away utterly convinced the day would come when we would all be carrying multiple Wi-Fi devices. Of course, that's already upon us. But I also walked away thinking about how Wi-Fi infrastructure was traditionally deployed and started thinking about the scaling challenges. In that world, when we're all carrying multiple Wi-Fi devices, just tacking up more and more APs all over the place gets to be a challenge. And so the idea was to come up with a way to scale Wi-Fi on the infrastructure side better than just tacking up APs. And the concept at a high level was borrowed from the cellular industry. Next time you're driving down the highway and you see a cell tower, take a look at how this industry, a decade earlier than Wi-Fi, scaled up their infrastructure. It's not just one radio or one antenna per tower. They're putting up, in many cases, dozens per tower with directional antennas The net result is you're covering a much larger area with fewer towers, so economics work better, and you're getting more capacity because you have more radios in the air. So that idea was then, so how do I take that cell tower concept, bring that indoors, and make it essentially an indoor Wi-Fi cell tower? How do I pack as many radios as we possibly can? And so the original product design we started on back in 2004 packed 16 access points into a single device, each with a directional antenna and with software and hardware that made all that work. I'm sure you guys have experienced trying to take multiple access points in close proximity. They don't cooperate. You can't just duct tape 16 APs together and stick them on the ceiling. So there's a lot more technology behind that. When we get to the architecture section, and I invite our viewers to tune into that segment, we'll go into a deep dive about how we make all that work. Since then, since we started out with 16 radios, we've actually expanded the portfolio at this point to have everything all the way down to your traditional 2-radio omnidirectional access point. We started with the toughest problem, and then we scaled down to 8 radios, to 4 radios, all the way down to 2 radios. So today, the portfolio spans the entire range of access point products. All of these are controllerless, has the controller built in. And from there, we've also extended the product line to outdoor products that have multi-radio capability and external antennas. So this is becoming a larger part of our business as we start tackling more outdoor stadiums and arenas, and bring that up as well. Common software, common feature set, cloud controllable today across the product line. And from a hardware perspective, just recently we've also introduced wired switches. Think of these just as PoE with a switch hanging off the back. We have to power all these devices, so we provide these as a means to do that. And as I mentioned, we also provide a rich set of software that starts from design services, both as an application and now as a cloud-based service to help you design and come up with basically a bill of materials based on your floor plan, based on your needs. That's available online as a cloud service as well. And from there, we also have a cloud-based back end that does initial bring up and initialization. It'll get your devices licensed, it'll do an initial configuration push, it'll actually get your system up and running when you just, as soon as it shows up, you plug it into the wire and it's all configured, pre-configured for you from the cloud. And then we have a very deep and rich set of management tools in what we call the Xirrus management system, XMS. We'll be demoing this later in one of our later sections, so again, for those of you viewing, please tune into that segment as well. But you'll get a deep dive into how we manage the network, what the tools are that we offer. And again, this is available both in an on-site application as well as a cloud-based service. So that sort of takes you through, at a high level, all of the sort of product portfolio. I'm going to ask Bruce to come back up on the product marketing side, sort of walk through our differentiation. So thank you.
All right, thanks, Dirk. I'm Bruce Miller. I run the product marketing at Xirrus, and we're going to talk about the 5 key differentiators. So Xirrus is uniquely positioned in the industry with an architecture that I'm sure we're going to talk a lot more in detail a bit later. But what makes us different, and why should you care? One thing that comes up right off the bat with what we do, and Dirk talked about the architecture, it's multiple radios. So we put more into one device, and when you do that, you end up deploying fewer devices into the network. And this can be anywhere from 2 to 1 up to 10 to 1. We have some convention center installations where they put 8 times, 10 times as many APs as they would put a Xirrus product. And this becomes a fundamental consideration when it comes down to the economics of the deal.
Can you guys just, thank you.
Sure. Yeah, we got to move this a little bit. So a 10 to 1 ratio, 4 to 1 ratio, whatever you have, that results in a lot less infrastructure on the back end. And we have some customers in the financial districts up in the Northeast, for example, convention centers that I mentioned, where they might be paying $750, $1,000, $1,500 per cable drop So it's actually more than an AP itself just to get a cable out to those locations. In school districts that we sell to, our kind of rule of thumb number is $150. So it really depends on where you're at and if union labor is involved, et cetera. But the fundamental issue is that it can cost a lot to put more APs. And by putting fewer, you save all of the back-end infrastructure tied to that. So that TCO is a key example of what we bring to the table, what we see a lot of customers come to us for because they don't want to run extra cables. They want to be deploying as little as possible. Casinos is another example of this actually, where they want to run as few things as possible to have hanging from the ceiling. Upgradability, we'll talk a little bit about this later, but we have a modular architecture. So a fundamental element here is the fact that I have the ability to snap radios of different types and technologies in and out of the system. And we've been doing this since the initial days of the company. I came on board about 6 years ago. We were shipping ABG. A couple years later, we had 11N, and we actually upgraded thousands of units in the field, sent them back, updated the radios, and updated the software, and they were running 11N. So we've already done that once with the transition to 11N, the same thing with the transition to 11AC, and we'll talk about that a little bit later, and we'll show you some 11AC hardware that we have in play. Third thing, spectrum optimization. So as you're very well aware, we are moving more and more to 5 gig. And Xirrus, as a company, we've been very much 5 gig focused since the inception of 11A, going back to the initial days of the standards, because we saw so much more spectrum, so much more capacity there. Now it's caught up. It's taken a while for the industry to catch up. The smartphone in some ways kind of took us backwards about 5 years ago because they all came out with 2.4, even though most laptops were starting to adopt 5 gig. But we're finally now getting back to the place where more and more devices are 5 gig. And just as a quick visual, there's 21 channels here in the US, and different countries have different numbers, but that would take me 21 APs to actually leverage all that spectrum. When I can software program my radios, I can do that with as little as 2 arrays actually. I'm just showing 3 here. But I can mix and match the bands to take advantage of that capacity. And when we talk about performance, when we talk about scale, that's a key element to consider. The fourth one is distributed intelligence. So no controller, at least no central controller. It's all integrated within the array. So you have basically, I like to describe it to a lot of folks as a switch with Wi-Fi ports. You don't have controllers to control a switched environment. You don't have to backhaul the data or do the encryption centrally. You distribute that intelligence. You put the processing power out at the edge in every single device. And as we scale up to multiple radios, we have a scalable architecture that has all of the power directly in the array itself. So this talks a little bit about DPI. We'll talk about that a little bit in a second here. We do DPI directly in the array. That's going to scale. If I have 100 arrays, I'm adding horsepower, I'm adding layer 7 intelligence as I add devices, as opposed to a single point in the network. So different kind of use cases. It doesn't necessarily work the same for everybody, but this allows a very scalable and reliable, resilient architecture. And then finally, application control. So we introduced this close to a year ago in our product line, the ability to dive into the packets at the application level, understand what applications are running. We recognize close to 1,200 different apps of all types. And then more importantly, we can then apply policies to that. So we can look at the application, we can rate limit it, we can block it, we can prioritize it. I want my critical apps, my business apps to be prioritized over my recreational apps. You have a lot of conflict these days with streaming video, BitTorrent, these types of things on networks, especially when you open them up to BYOD. So it's very critical as we move forward to look at that spectrum as a valuable resource and apply optimization techniques to it. In fact, we make the analogy a lot of times with the WAN optimization. The WAN was the choke point of the network where you paid for those megabits and you wanted to optimize it, so there's a lot of WAN optimization companies that came out. You really look at the Wi-Fi in a similar way. The cores of the network, they have 10 gig, they got high capacity, but the spectrum on the wireless side is actually a limiting factor for many situations. So optimizing it by understanding the applications is a very key element of allowing scalability, density, and performance. Okay, so how does this translate then to specific use cases? So just real quick, give you kind of a bird's eye view. You can go from low density scenarios, a warehouse, I might have a device every 500 to 1,000 square feet, all the way up to very high densities. Imagine a stadium where I have fixed seating, everybody is in a seat, potentially could have a device, I could have one device every 5 square feet. Orders of magnitude difference in terms of scalability. One product in our minds does not fit all of those scenarios. I might have an AP in one case, I might have a very large 16 radio array in the other case, and you have all these scenarios in between. And that's how we approach it, is apply the technology, the density, capacity for the application. Quick visual on that will help. I have a school, I have lecture halls, I got classrooms, I got the machine shop, I got offices, all different kinds of use cases. I can deploy APs in that environment to cover that as I normally would, and we have products that'll do exactly that. Or I can do something more like this. Let's put the density where the people are. The lecture hall in the middle gets a larger capacity device instead of 4 APs. And I spread that out to the edges of the network. Maybe I still have APs in the, where the gym teacher is sitting off in the corner of the building. You deploy the density where the people are. And more dramatic, a convention center. So here I can get into hundreds and easily thousands of APs. We're in the Sands Convention Center in Las Vegas, one of the largest convention centers in the US, over 2 million square feet. They had a quote for an AP coverage of 1,500 units. We came in and did it with 190 arrays. So again, the economies of scale are very critical to that kind of deployment. It's most dramatic in these kind of scenarios, but when I can start to aggregate a lot of density and capacity into one device, I have a significant advantage by deploying less equipment. Okay, so that just kind of sets the stage here. We'll dive into the architecture. 3 fundamental things, though, that just to kind of summarize is that upgradability. Why do people look at Xirrus? High performance and scale, and then the TCO value proposition.